So 31 through 39 was on yesterday's, but I didn't get to teach to that far, so now it's been thrown on to today's. So everything on this homework is about circles. So let's talk about circles. So yesterday we talked about distance between 2 points. So I'm going to put a point here. I'm going to put a point here. So like the distance of that segment. Well, I could also look at this, that this is a circle. This is the center. That's the radius. And yes, I can't draw a circle, but... And so all of this would be a radii, whatever this is. This is congruent to this, to this, to this, to this. So I'm going to go ahead and I'm going to look at that one point. I mean, the circle's made up of a whole bunch of points. So I'm going to use Pythagorean theorem. Well, to plot that point, which is an xy point, this distance would be x. This distance here would be y. And this distance here, we'll call it r for radius. So for Pythagorean theorem, it's x squared plus y squared equals r squared. That is not only Pythagorean theorem, it's also the equation of a circle centered at the origin, or in other words, 0, 0. So, let's see here. Go write the equation for that circle. And I'll write it right behind you. Right? The equation of any circle centered at 0, 0 is this. So just so you tell me the circle is centered at 0, 0, I don't need to use that. I just need to use the radius. But again, the radius, that means squared. So it's 49. I don't leave it as 7 squared. I usually write it as 49. So now let me try it the other way. There's an equation of a circle. Please tell me what the radius is on your paper. Radius equals what? Right? Because we know from the equation of a circle that r squared equals 2. But I just want to know what r is. So I'm going to take the square root of both sides, and it's usually plus and minus. But if I'm dealing with a real-life object like a circle, a radius, then I'm only going to use the positive. So r equals the square root of 2. Because I know I'm actually dealing with radius, not just some generic variable r or x or y. It's actually a radius, so it needs to be a positive distance. Is that okay so far? Now I'm going to go ahead and I'm going to shift the center of that circle. That's going to be the center of my circle now. I don't know. Let me see. Let me give it an order pair. Let's give it an order pair as 3, 2. So that must be, well, that's a really sad drawing, but that's okay. 3, 2. In fact, if you don't mind, you go ahead and do it better on your paper. I'm going to do it better also. 1, 2, 1, 2, 3. I just did it better. It's more accurate. So now I think I'm going to go ahead and have a radius of 2. So to sketch that out, 1, 2, I go in the 4 different directions. 1, 2, 1, 2, 1, 2, and then I can sketch in my circle. Centered at 3, 2 with a radius of 2. Well, I know that if it was centered at 0, 0, that would be the equation. Except what I did is I translated it to the right 3 units, and then I translated it up 2 units. So in fact, that is now your new equation when it's centered at HK. Counterintuitive on both. I know we're used to vertical shifts or translations being intuitive, but you notice I put it inside the function, so it has to be counterintuitive. It has to be the opposite of what you think. So let me try. Centered at 1, 5 with a radius of 4. Write that equation. Write the equation of that circle. Attempt that to the best of your ability. That should be what you got. X minus 1 quantity squared plus y minus 5 quantity squared equals 16. Is that okay? Not just raise your hand or something, or get my attention. I want you to tell me what the center is, what the radius is, and I want you to give me a rough sketch of it. Of that circle. Again, this all came from Pythagorean theorem. Just like our unit circle that you did last year. On both of those, that's inside the function. Remember, it's counterintuitive. It's the opposite of what you think. So if I know the center and I know the radius, I can sketch out my circle. any of this hard? Do I need to go over more? I don't need to go over more problems if you get it. Is it okay? Or in other words, see if I can find a simpler question. Who wants me to do more examples? Okay, I will do. I have a couple of requests, so let me do a couple more. At least one more. Okay, you can see my circle. You can see my center. What I want you to do is I want you to tell me the equation of the circle, the center, and the radius. Hello? Uh-huh. Uh-huh. I won't, but I'll try to get it myself today. Thank you. Bye. How was that? Did I do enough examples? Is that okay now? I tried it every different way to come at it to make sure you understood. Okay. I'll go ahead and I'll take this one and I'll do the next part. This is the general equation of a circle. Okay, what did I just do? What did I do to get from here to here? I just multiplied it out, just expanded it, right? I just did the square, got two of them, did the square, got two of them, multiplied it all out until I had a bunch of terms. Then I organized it with x's first and y second, but in order of powers. X squared, x to the first power, y to the first power. I threw all the constants here and I put a 0 on this side. I mean, it really doesn't matter which side here, but this is usually how you're going to see it given to you. Well, you're not going to go this way. Actually, what you're going to do is you're now going to go this way. What you're going to get is these, and we have to learn how to go backwards. I just wanted to, if I just gave this to you, you wouldn't know where it came from. So now all the problems, you now know where they came from. They came from the original, this is called the standard equation of a circle. They just multiplied it out and got this general thing. And from this, can I see the center? Nope. I can't see the radius. I can't see anything. I can't see anything. Let's see if we can remember back in the day. It's a parabola, quadratic. So the vertex is 3, 4. This is called vertex form. It's called vertex form because I can see the vertex. Right? I can see that. Vertex form. That was beautiful. But I can take this and multiply it out. I don't know what it is. I'm just going to make up what it is. Can I see the vertex? Nope. The only thing I can see out of that is the y-intercept. It happens to be -3. Oh, yay, that helped me a lot, right? But with a vertex, that tells me a lot. 3 and 4, and I know it opens up. I can at least do a rough sketch. I can't do a rough sketch when it's a point. So I don't like standard form of a quadratic, but I love vertex form. Same thing here. My general equation of a circle, I literally can't see anything. I can't see a darn thing. So I wish I could change it back to this form, well, which we're going to learn how to do. And then this way I can see everything. From this, no t-tables, no nothing. I can sketch out the graph very quickly. Very quickly. Just like you can sketch out the graph of the quadratic. We did it last year. Oh, and you'll do it again this year. Oh, and you already did it, and you're going to get to do it again. No big deal. So let's learn how to do this. So I'm going to take that problem. You can just leave off right where you left off. We already know what the answer is. What is the answer? It is this. That equation of a circle in standard form, I can tell everything. I can sketch it. From this, nothing. All right, give me some ideas. Put the x's and the y's together. All right, let me do that. Uh-huh. I love that. That was a great idea. Okay, I could do that too. Well, yeah, I want numbers over here, don't I? I like that. Well, it looks like somehow I've got to get it to look like this. This stuff, I need it to look like this. What is that again? Let me expand that out. It's 3 words. And you've done it before. I didn't say you liked doing it before, but you did it last year. And in algebra, 1. Not name, that thing is in the name. What is that thing? It has to be a C, a T, or an S. What is that? I need to do this to make it look like that. Oh. See, I knew it was in there. Okay, complete the square. All right, let's go complete the square. Not once, but twice, because here's the square. That's a square. That says that this square is x minus 1 and x minus 1, right? Because the area is x minus 1 quantity squared. Side time, right? That's a square. So let's go complete the square. Oh, how do I do that? How do I do that here? Let's just focus on this guy here. I want to complete the square. I need that other number. How do I complete the square? Okay, it's okay. I'll help. Quadratic. That one right there with the 2. You know what? I wish I'm working. Oh, it's bad. Remember that generically, right? I need those letters A, B, and C. I need you to remember that. So this guy here is going to be, so what is that going to be? What is my B in this part here? What kind of 2? It's a -2. The B is only the number in front of x, not the x. So I want -2, cut it in half. That's a -1. Quantity squared, oh, that's +1. Yeah, duh, there it is. And what I do to one side, I got to do to the other. Because somehow I got to get up to 16, don't I? I'm at 7. Woohoo! Let me go ahead and complete the square here. Y squared minus 6y. Okay, what's my b in this part? -6. Cut it in half. That is -3. Square it. Right? And what I do to one side, well, let me do it down here. Is that, did I get my 16 that I wanted over here? Okay, I've got my 16. And that y squared is positive, so I'll put my plus in there. Now I have to go and factor this. Well, just in case we forgot, let's do some old school factoring. The only way to get a 1 is with 1, but I need to be able to add those two up to get negative, so it's negative. Oh, they're identical, so I'm allowed to write it like that. Sorry. Didn't realize it's going down too low. Again, let's do some old school factoring. Y and a y. The only way to get a 9 is either 1 times 9 or 3 times 3. Well, if I want a 6, I want to use a couple of 3s. So they have to multiply to be positive. That's either both positives or both negatives. I want both negatives. Oh, they're identical. That means I could shortcut it like this. And I am done. Now I can see the center and the radius and I can sketch it out. That's not an issue now. So I just have to complete the square twice. Oh, yay. Yes, ma'am.
So you always use that equation method with the b over...
That is how you complete the square, yes. Value is the b over 2 quantity squared, and I like going through this process so you understand where this came from. It isn't from magic of formulas, but you could go also straight to here next, and this is really just b over 2, right? My b was a -2. -2 divided by 2 is a -1, right? So this is really just the b over 2. This one here was a -6. -6 cut in half is my -3. But it's better to kind of make sure you understand the process and not just tricks. I have to give you this one, though. I'm not going to go through the long proof of where all that came from.
I have a question. You know how on the other side you put 6 plus 1 minus 9? Why isn't it -6? Wait.
How'd you do that?
Yeah, like why is it positive if you have to take away and put it on the side? It would be negative.
Okay, so when we complete the square, sometimes we leave a 0 over here. Like when we were doing vertex form, we might keep a 0 here. So when we add to one side, we also subtract it, which might be what you're thinking of. Go back to equations. If, boring, oh my God, I wish I had a marker on this side. What you do to one side, you have to do to the other side of the equal sign, right? So just use that. So this is what I had, right? We threw this on this side, which we legally can do, make that a +6. But from completing the square, we just plucked out of the air a 1. We added 1 to this side, so therefore I must add 1 to the other side. I added a 9 by doing this thing called completing the square, but I literally added a 9 in this lineup. So I must add a 9 to the other side. What else can I help you with? Let's do another one, right? Let's do another one. So I'm going to do the evens of your homework. So it's asking for three things in the directions: the equation, the center, and the radius. So the first thing that was said to us, suggested, was to gather up all the x's, gather up all the y's, and then throw the constant to the other side, because that's where we want it. That starts building our radius. I'm going to leave some space. I hope that changes, because I can't have a radius be negative. But I'm not going to worry about it right now. I'm going to come back over here and complete this square. So what value would you like me to add here? 16, right? Take my b, cut it in half, and square it. Oh, good. At least I got my radius up to 0. What do I add here? So now my radius is 4. That y squared is positive, so I can put that in there. Remember, right here I said you could, it's better to know how to factor this, you could just do b over 2. If you don't trust yourself, you can always go back and verify you got the right numbers. So I think I'm good with this. Now I can answer, well, I've already done that one. My center is what?
-4,
My radius is? 2. Common mistake. You guys are screw up on the radius. Common mistake. Is that better? Okay. Do you want me to do one more? One more. Okay. What would you like me to put here? What's the formula? B over 2 quantity squared. What's the other one you want me to do? Same thing. What is this going to be?
But why is it 1/4?
So what is this going to be? You can always double check your math. Okay, I must like my math because it came out the same. So the radius is 1. The center of the circle is -1/2, -1/2. And this is my equation of my circle that I got that information from. If I try to graph it, that would be teeny tiny, but I could graph it. Tell me the center, tell me the radius, and tell me the equation of the circle. Now I just made it more difficult and I tied it into yesterday. You will be stuck. You will need to talk to each other. Sorry. Thank you. Thank you for that. See, as soon as she was like, I did something wrong. Well, yeah, I did. I don't need to have this part recorded because none of these are in your homework. They used to be. Now I just use it as an extra problem here in class. So I'm going to stop the recording.